Okay, Wildcats. Today we're looking at Wednesday, April 25th, composition of functions on page 78. Who would update your table of contents? All right, now your table of contents are updated. Let's take a look at your notes. All right, composition of functions on page 78. F of g equals f g of x. G of f equals g of f of x. A little note, put one function inside of or in place of x. That's basically what composition of functions is. All right, if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, so write each composition function, state the domain and range. Okay. All right, so f g of x. So that's f. We're putting g of x into f, and g of x is x squared. So we're putting x squared into the function f. Okay, so f of x is 1 divided by 2x, so we're going to place x squared where the x is. So that's 1 divided by 2x squared. So now when you look at the domain and range. Now this doesn't look like one of the functions we've looked at before, so let's graph it to see what the domain and range looks like. So we're going to go to on, new document, add graph, control divide 1 divided by 2x squared. All right, so it looks like it has a very unique domain and range, and something's happening here at 0. So let's go to control T, look at 0. Looks like 0 is undefined, okay? And let's look at it and explain why, okay? So the reason that is because you can't have, remember, a number divided by 0 is undefined, okay? Undefined. All right? So we know that if we set 2x squared not equal to 0, we divide by 2, take the square root of both sides, we know that x does not equal 0. So that's a restriction, okay? And that restricts the domain. So our domain, looking at it from the graph, okay, looks like it goes from negative infinity to 0 and 0 to infinity. Okay, so that's negative infinity to 0 or 0 to infinity. Now the range looks like it never reaches 0, but everything is greater than that. So the range would be from 0 to infinity. Okay, so now let's take a look at example 2. All right, example 2, so that's g of f of x. So that's g of f of x. Now f of x is 1 divided by 2x. So we're putting in 1 divided by 2x in for x here. That's being squared. So that's 1 divided by 2x squared. So 1 squared is 1, 2 squared is 4, x squared is x squared. So we have a similar situation that we did in example 1, in that we need to set 4x squared not equal to 0, divide by 4, take the square root. We know that x does not equal 0. So for our domain and range. Now, in essence, example 1 and example 2 the same type of function, so we know the domain and range format is going to be the same. Okay, so it's negative infinity to 0 and 0 to infinity. And then the range would be from 0 to infinity. And you could graph that to verify. All right, now let's look at example 3. So we have g of h of x. So that's g of h of x. Now h of x is x minus 8. So we're plugging in x minus h in for x. So we're squaring x minus 8. So that's x minus 8 squared, which is x minus 8 times x minus 8. So now we FOIL. So x times x is x squared. X times negative 8 is negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 is a positive 64. Okay, so now we have x squared. Negative 8x minus 8x is negative 16x plus 64. All right, now for the domain and range. Now we know since it's quadratic, the domain is from negative infinity to positive infinity. Now we know that since it's x squared, it's facing upwards, and we know that 64 is the vertex, so that's the lowest point. So it's going from bracket 64 to infinity. All right, now let's take a look at example 4. So that's f of k of x. So k of x is the square root of x. So we're putting in the square root of x in for x. So that's 1 divided by 2 square roots of x. Now you can't have a radical in the denominator, so we need to rewrite this as 1 divided by 2 times x to the 1/2. And then we need to multiply x to the 1/2 by the numerator and denominator. So when we do that, we get 1 divided by 2. Well, first of all, 1 times x, that's x to the 1/2. And then when you multiply these, you add. So 1/2 plus 1/2 is 1, so that's 2x. So that equals, we're going to rewrite that as the square root of x. So the square root of x divided by 2x. Now, that doesn't look like a function we've seen before, so let's go ahead and graph that to see what the domain and range look like. So we go to on, new documents, no, add graph, control divide, control square root of x divided by 2x. All right, so looking right here, it looks like the domain, it looks like the graph is getting very close to 0 but never touches. So domain is from 0 to infinity, not including 0, and it looks like the same thing's happening on the y. So the range is from 0 to infinity. All right, so now let's take a look at example 5. All right, example 5, find the value. So that's k of g of 2. Now we're finding the value. So they're actually giving you a number for x. So g of 2, well, you're putting in 2 into the x, so that's 2 squared. So that's k of 2 squared, which is k of 4. Okay? Well, you're plugging in 4 into k, so you're doing the square root of 4. Now remember, square root is plus or minus, so that's plus or minus 2. Oh, wait a second. That's not k, that's an h. So slight change. So everything applies. That's h of 2 squared, still 4. So h of 4. But now instead of going to the k function, we go to the h function, which is x minus h. So that would be 4 minus 8, which equals negative 4. All right, let's take a look at example 6. So that's f, and make sure I get the function right this time. That's f, okay, of k of 4. So we're plugging in 4 into k. So k is 4, so that's the square root of 4 so that's plus or minus square root. So what we really need to do is do this twice. So let's do f of square root of positive square root of 4 and negative square root of 4. So that is the square root of 4 is a 2, and the square root of that is a negative 2. So we're plugging that into f. So f is 1 divided by 2x. So we're plugging in, that's 1 divided by 2 times positive 2 equals 1/4. And then that's 1 divided by negative 2 times 2, which equals negative 1/4. All right, so now let's take a look at example 7. All right, write each composition function, state the domain. Okay, so, and actually not just domain, domain and range. All right, so that's f of g of x. Well, g of x is 2 divided by x minus 1. So we're plugging that into f. So that's equal to 5 times 2x minus 1 plus 2. So that equals 5 times 2 is 10. That's 10 divided by x minus 1 plus 2 divided by 1. Now, in order to combine these have to have the same denominator. So we need to multiply this times x minus 1 divided by x minus 1. So that's 10 plus 2 times x minus 1, since they now have the same denominator, divided by x minus 1. All right, so we ran out of space here, so let's come down here. So now we're going to distribute and combine terms. So that's 10 plus 2 times x is 2x. 2 times negative 1 is negative 2, divided by x minus 1. So then we combine 10 and 2 is 8, so that's 2x minus, or I'm sorry, 2x plus 8, divided by x minus 1. We can factor out a 2 from here, so that's 2 times x plus 4 divided by x minus 1. All right. Now, to understand the domain and range, we go back to when we had the horizontal asymptote, vertical asymptote, and so on. So first off, we want to look at the vertical asymptote. Now, to find the vertical asymptote, you set the denominator equal to 0. Okay, so that's x minus 1 equal to 0. So the vertical asymptote is x equals 1. Now we need to find the horizontal asymptote or slant asymptote. Okay, to find that, we divide x minus 1 into, and we'll come back to the 2x plus 8. Okay, so you ask yourself, well, what do you multiply x by to give you 2x? Well, the answer to that is 2. So we know our horizontal asymptote is 2. So now that we know the vertical asymptote, horizontal asymptote, we can do the domain and range. All right. Now, the vertical asymptote affects the domain. So we know that it's going to be from negative infinity to 1 or 1 to infinity. And then the horizontal asymptote affects the range, so it's from negative infinity to 2 or from 2 to infinity. All right, so let's take a look at example 8. All right, so we have g of f of x. Now, f of x is 5x plus 2. All right, little awkward pause there. All right, so that's g of f 5x plus 2. So we're going to plug in 5x plus 2 in for x. So that's 2 divided by 5x plus 2 minus 1. So then that's 2 divided by 2 minus 1 is 1, so 5x plus 1. Now, just like from example 7, we're going to find the vertical asymptote and the slant asymptote. So the vertical asymptote, you set the denominator equal to 0, so 5x plus 1 equal to 0. You subtract 1 divided by 5, x equals negative 1/5. Now for the horizontal slant asymptote, again, we divide 5x plus 1 divided by, now here's the thing, you don't want to just divide it by 2, you actually want to do 0x plus 2. So then you ask yourself, well, what do you multiply 5x to give you 0x? Well, the answer to that is 0. So the horizontal asymptote is 0. All right, so now we have that. We can do domain and range. So domain is, that's with the vertical asymptote. So that's from negative infinity to negative 1/5, or from negative 1/5 to infinity. And then the range is from negative infinity to 0 or 0 to infinity. All right, so at this point, if you understood the example, start working on an assignment. If you have some trouble with the examples, then you can work with me on the assignment in class on Wednesday, April 25th. So with that, have a wonderful Wildcat day.